Good day to all of you. Welcome to ODL session. This is Managerial Economics class, week 5, lecture 6. Today we are going to discuss a case study relating to law of variable proportion. Let us get into the class. The case study is given in the following way. Consider a production of food grains in a piece of land in which the variable factor input is labor and fixed factor is a machine. So, one fixed factor input and variable factor labor. So, they have given the values. First labor, second labor up to 10 laborers. When they employed, the total production is 10, 22, 36, 56 up to 78. So, this is the output when the labor is employed one by one. With the given information, they are asking us to find the average production with the given output. First, we have to find the average production. Then the second question is find the marginal production. And the third question is mention the point of inflection. We have to calculate the point of inflection. And fourth question is diagrammatically express the total production, average production and marginal production. And the last one is they are asking a suggestion when we have to employ the laborers, when we have to deploy the laborers. So we will solve this particular case study. First we have to construct the table. With the given information, the first three columns is one machine and variable factor is labor. So in fixed factor I put one in each column. In fixed factor I put 1 in each column. The variable factor, that is number of laborers, it is increased one by one. 1, 2, 3 up to 10. The third column, it is also given in the case the sum. So the first laborer producing 10 units. The total production is 10. When the second laborer is employed, it is increased to 22. When the third laborer is employed, the total production is 36. Likewise, it is increasing. Subsequent employment of laborer, the total production increase as 52, 66, 76, 80, 82, 82 again and 78. So, the first three column is given in the problem itself. So, the first question is find the average production. How to find the average production? It's very easy. The formula for average is total divided by input employed. Here the total production is given in the third column. The input employed is the second column. So the average production is nothing but third column divided by second column. You can see total production is 10 when first laborer is employed. 10 by 1 is 10. Then the total production is 22 when the second laborer is employed. So 22 divided by 2 is 11. For the third employer, 36 divided by 3, it is 12. So likewise, the fourth column, fifth column, we have to calculate the third column divided by second column. So this is the way we have to calculate the average production. Now let us move to the second question. The question is find the marginal production. Marginal production is nothing but what is the additional production because of the employment of that particular input. When one laborer is employed, it is 10. So the marginal productivity of the first laborer is 10. When the second laborer is employed, it is increased to 22. So what is marginal production? 22 minus 10. So it is 12. So how to calculate this marginal production? Current column minus the previous column. In the third laborer, 36 is the output. The previous output is 22. So 36 minus 22 is 14. Likewise, we have to calculate the marginal production. So the values goes like this: 10, 12, 14, 16, 14. Likewise, in the seventh laborer is employed, it is 80. 80 minus 76 is 4. Then it is for eighth laborer, 82 minus 80 is 2. And the ninth laborer is employed, there is no change in output. That is why the value in the ninth column is 0. 82 minus 82 is 0. In the 10th laborer, it is output is only 78, but the previous output is 82. So 78 minus 82 is minus 4. That is a negative production. Why? Because too much labor is employed, so the output is reduced. It's a negative productivity. So the first question is average production, third column by divided by second column, and marginal production. Second question is marginal production. Second current column minus previous column value in the total production, that will give the marginal production. So the third question is how to find the point of inflection. So what we have to do first, based on that particular table, that table, column 1 represents fixed factor, column 2 represents the number of laborers, and column 3 represents the total output. These three are given in the sum itself. So column 4 is the average product. Just now we have calculated. How to do third column divided by second column. The last column is marginal production. It is calculated the difference between the total product and the previous value. These three curves diagrammatically represented like this. When we measure the variable factor, number of labors in the x-axis and the output in the y-axis, then the values of total production, marginal production and average production will be plotted. So where is the point of inflection? The point of inflection is coming when the fourth labor is employed. First we should know what is point of inflection. For that, first we should divide the particular production schedule into three stages: stage 1, stage 2 and stage 3. In the stage 1 itself, the point of inflection is coming. In the first stage, the total product increases at an increasing rate till the point of F. Why? Because the fourth labor is employed. After that point, the total product is increasing, but not in an increasing rate, but decreasing rate. At this point, the marginal product is maximum, and after that point, it starts diminishing, but it is positive. This point F in the total product is called point of inflection. As the total product changes its output from increasing rate of increase to decreasing rate of increase. As total product and average product are increasing trend, but the marginal product also increasing and it reaches the maximum. This stage is called increasing return stage. For your better understanding, I will explain with the diagram. So I am going to the previous slide. You can see the marginal product is 10, 12, 14, it is increasing. Up to the fourth employer, it is increasing the increasing trend. That is from 10, it is increased to 16. But after the fourth labor employment, the marginal product is increasing, but not in a increasing rate, decreasing rate, because it is 14, 10, so it is reducing. So the change from increasing rate of increase to decreasing rate of increase is called point of inflection. This is increasing return stage. The second stage is diminishing return stage. Why? The total product is increasing at a slower rate to the increase in the variable factor and reaches a maximum level when the marginal product reaches 0. Both average product and marginal product declining, but it is positive in this particular stage. When the second stage will end, as the marginal product is diminishing and reaches 0, this stage is diminishing return because the marginal product is declining, but total product is increasing in a decreasing rate, but it is coming down. In the third stage, it is the last stage. The total product start declining, which results downward slope of TP curve. Why? Because the marginal product is negative. The average product also decline, but coming closer to the axis, but it never touches the axis. But the marginal product curve intersect the x-axis and move further and become negative. Therefore, it is called negative return stage. For your sake, I will show the diagram. When the ninth laborer is employed, the marginal product reaches 0. When 10th laborer is employed, it is minus 4. So that is why in the third stage, the total product is decreasing as the marginal product is negative. That is why this stage is called negative return stage. And the last question is, give suggestion for employment and deployment of labor to get the optimum return. Considering the stages of log variable proportion, a rational producer will not stop in employing the labor up to the stage 2. And in stage 3, the producer has to decide not to deploy additional laborers. A successful manager will expand the business during the first 2 stages only. And once the marginal product reaches zero, further expansion lead to negative return. So we should not employ or deploy the labor for the production. The law of variable proportion gains its importance as it can operate under the scarcity of various factors of production and the clarity in the input-output ratio of the production in terms of number of laborers. Professor John Robinson has rightly pointed out that the law of variable proportion indicates the limit to extend the input factor to reach the maximum level of output. So the stage 1 can be considered as an expansion of production, and stage 2 is a range of rational production, and no further expansion should be made in the third stage. So in this way we can solve this particular case study. If you have any doubt, you can ask me. I am Dr. Chandrachud, Professor and Head Department of Economics, School of Management Studies and Commerce, Wales Institute of Science and Technology and Advanced Studies. This is my email ID and this is my contact number. We will meet in the next class. Until then, goodbye.